Okay, sorry, just one more time. This was sort of an impromptu live session. It's not one of our normal ones, but I wanted to go through finish up the review for the exam that most people are working on right now, and it's not due until, I believe, Thursday at midnight, if I'm recalling correctly. Yep, Thursday at midnight. So if it's not done yet, that's a-okay. And going through this list, we did the vast majority of this before the break as far as review goes. And I just wanted to clean up a little bit about maybe do a bit more about functions, fruitful and void. So if there is anything on this list that you don't recall doing in the last review session, please let me know, and I'll go through that as well. But I'm going to focus mostly on functions and maybe a little bit more on casting data into the proper form, but I know we did a lot of that in the last session. So if you weren't with us for the last live session, which would have been the Wednesday before the break, it might make sense to go back and watch that session because, as I said, we went through the vast majority of this. So I'm going to flip over to Python. Romilly, you got your mic on. Can you tell me, can you see that okay?
Yeah, I can see it.
Okay, good. All right, so functions, we work with them. When we work with them, they're very similar to what we did in Reborg. Some of the commands obviously are a little bit different because essentially everything in Reborg is a function. The move is a function, turn left is a function, and you could create your own functions. Well, we don't have a graphical interface. We don't have a Reborg now, so move doesn't mean much, but the way that we set up our functions is very similar. The big difference to functions now that we're doing them, we're coding them in Python with the proper Python syntax, is that we're going to be dealing more with fruitful functions and with returning values and sending values to our functions, which is something that we never did in Reborg. So that's kind of the new part of it. So let's just say that we want to have a program that takes a dollar figure from a user, computes tax, returns tax, and then computes final bill, let's say, or total or whatnot. So let's just say that you're buying something online and there's a price attached to it, and then you want to find out both how much tax you're paying, and then you also want to find out what the total bill is going to be. So we need to be able to take input from a user. We need to be able to send it to a function, and then we need to be able to receive something back from the function in order for it to be considered a fruitful function. And most of our useful functions moving forward are going to be fruitful functions. So we'll do fruitful functions first because really they're the most important. Okay, so let's just set up a bare bones function, and then we'll go back and we'll kind of add to it as we need to. So let's just call this first one tax. Okay, so we'll call the function tax, and we're going to send the function some data. We're going to send it a price so that we know how much tax to get back, so we can compute the final price. So we'll start with a function that we're just going to call tax, and because we need to send it something, we need to send it the price of whatever item we're buying. I'll just call that variable price. So in setting up my function this way, I've got a function name. It's called tax. So whenever I call the tax function, it knows where to find it. And B, the tax function knows that it needs some data in order to work properly. If it doesn't get the price, it can't compute the tax. All right. So let's just set a couple of local variables. Remember that these variables are only available inside this function. You can't access them from anywhere outside the function. So we'll set the GST, and the GST is going to be 0.05, and that's 5%, right? So 0.05 is just 5%. And we'll set a PST, which I believe right now is 6%. So I have a GST and a PST, and those are hard numbers. Those are programmed in there. The GST isn't going to change. The PST isn't going to change. So I'm just making them local variables and setting them to a certain number, and we shouldn't have to change those. Now, if the GST or the PST changed, if the rate changed based on what the government decides, we could always go back in here and change those numbers. But for now, those are the numbers that they are. So in order to compute how much tax we're going to pay on an item, it's simple multiplication. We need to multiply the price of the item by the GST and the PST. And we could this is probably a bit more programming than you need to do, but you could make another variable here that's all taxes, and or sorry, both taxes. Let's just call it both taxes. I could have done this without the top two lines, but if we add both of those taxes together, it would be 11% or 0.11. So you could have just put in this one line here. I just put in the other two to show you where the number is coming from. And you know, to make it a little bit more programmer friendly, we would probably go both taxes equals GST plus PST, which is going to give us the same thing, right? It's going to give us 0.11. So just laying those out for you. So when we when we compute what the tax is going to be, we just take the price of the item and then we multiply it by the taxes. That's all we need to do. So what we're going to return, because remember, a fruitful function always returns something back to the main program. Right? So we send it the price of the object. It uses the price of the object and the numbers that we put in for the taxes. It computes the amount of tax we're going to pay, and then we're going to return it or send it back to the main program. So we send it something, and then we're going to receive something. For it to be a fruitful function, it has to have a return statement, and it has to return something useful. A fruitful function does not necessarily need to take data in. So just because our example is taking in the price, you can still have a fruitful function that doesn't take anything in and still returns a value to the main program. So I'll maybe do an example of that later, but for now, we're both taking in the price, and that's called an argument, and we're going to return a value to our main program. So what are we returning? I said it's pretty simple calculation. If you want to find the taxes, you just take the price of the item, and then you multiply it by the tax, which in this case is going to be our both taxes variable. Okay. Now, we haven't actually done anything. So if I run our program, all I've done is sort of set up our function. If I run our program, it runs and it does nothing, right? This is an error. This is a message from before. So I'll just clear this out. Clear all. So when I run my program, you notice it doesn't do anything. It doesn't give me any errors. There's no errors in the program, but I haven't asked it to do anything. It's just like in Reborg, if you had made a function to turn right, and you'd say, you know, def turn right, and then done a repeat 3 for turn left. That's how we turned right in Reborg. If you had just put that function in, but you hadn't put any other code or commands in your program, it wouldn't do anything, right? But we didn't really tell Reborg to do anything. We just said, hey, if you're gonna turn right, this is how you turn right. So in order to, you know, to make this program more useful, we have to actually do something with that data. So let's set a variable here, and we're just going to call it something different than price. You always like to have, even though this is going to stand in for the price within this function. Okay, price is only going to mean something within the tax function. It's not going to mean anything outside the tax function. So I'm going to create a similar variable, but with a different name, just so I keep everything straight. So maybe I'll call this one item price. Okay, so it's easy to tell that it's related to price up here, but it's not exactly the same thing. So I'll create a variable called item price, and I'll just set that to 0 right now. Okay, now we need to get some input from the user to find out how much the item that they want to buy costs. So we're going to have to change that item price, okay, and we're going to set that now equal to, let's call it a float, okay, because we always want to cast our data into the right format. Well, prices are going to have decimals, so we know it needs to be a float of some type. And then we know it's an input statement. We need to get something from the user, so an input statement. And then we have to give them a prompt, okay? So our prompt is going to be, how much does the item cost? So it's going to prompt the user to put in an item price, and then we have to use that item price somehow. Okay. So that'll be our next line in the program. So after we get a price from the user, let's just print out a line that says this is how much the tax is, and we'll worry about the final price later, right? Because right now all we're set up for is figuring out how much the tax is on the item. So I'll maybe put a print statement in, and I'll say the total amount of tax for this item is, and then maybe I'll put a $sign. I'm not formatting this perfectly for currency, but I'll just put a $sign in for now. And then after that, I'm going to put a comma, because remember, when we're doing print statements, if we're doing print statements with different data types, in this case, a string and a float, we want to use the comma instead of the plus sign, because if we use the plus sign, we can only use it for 2 strings or for 2 floats, or a float and an integer. But we want to have it for both. We want it to print out the string, and we also want to print out the tax, which is going to be a float. So using the comma allows us to do that without getting an error. So that's why I always recommend using the comma for concatenating, which means just putting together your print statements. And then it does it all on the same line as well. So the total amount of tax for this item is, now we're set up to get the total tax, but we have to call the function first. It's like a phone call. Okay, so we're putting in a call to the tax function, and then we're going to speak into the phone, and we're going to say, item price is this. And then on the other end, the tax function is going to do the proper calculations, and then it's going to send us back the answer. So it's kind of like a phone call, right? You send it some stuff, you call it up, you send it some data, it does what it needs with the data, and then it sends something back. So in this case, we have to call the function, so we know it's called tax, and then we also have to send it something because it's looking to receive a price. If we don't send it a price, it doesn't know what to do with it. Okay, so let's send it a price. And we already have a price because we asked for it in the line above. Okay, so all we need to do is call the tax function and put in the variable item price, because, sorry, just getting a window I got to get out of the way here. Okay. So we're calling the tax function, okay, and we're sending it the item price, which we got the line before, and we know that this whole chunk of code here is going to be replaced with whatever it returns. Okay, so it says tax item price, but when the computer goes to print this final line, it's just going to replace this entire chunk of code with whatever it gets back from the function. Now I think I might need one more bracket because it's inside a print statement. No, I don't. It's good. Okay, I've got 2 brackets on the end here because one of the brackets is for the tax item price function, and the bracket at the very end is the closing bracket for the print statement. So let's run this, and maybe I'll run it step by step. Yeah, I'll run it step by step using F7 in PyScripter, just to show you what's going on the entire time. I'll also bring up my variables window because that is always helpful for us to see what is happening with our variables as we go through the program. I just got to find my variables window. There it is. So I'll just bring this over here so that we can see what's going on. Okay. All right, so we're stepping through our program just using F7. So it's not doing anything at the top here. It's just basically checking and saying, is there a function? If there is a function, what's it called? So you'll notice it read this first line and then skipped over the other ones down to here. So now we should be making an item price variable and setting it to 0. So now you'll notice that when I go over that line, now I've got an item price variable. It's an integer, and it's set to 0. I also have a line here in my variables that's called tax, and you see how it says it's a function. So it recognizes that there is a function named tax, but it hasn't done anything with it yet. Okay, so let's do the next line. Now it's going to get input from the user, and it's going to cast it as a float. So it says, how much does the item cost? Let's say the item costs $4.99. So now that line's complete. And if we look at our variables, it's now added item price, and it's changed it from the 0 to a float because I told it to be a float, and it says the value is $4.99. So that all lines up with what we typed in. Now it's going to do this last line. So what the computer is going to say is, I want to print. First thing I'm going to do is I'm going to print this line that says the total amount of tax for this item is $, but then it needs to call the function. Okay? So I've told it to call the function tax and to send it the item price, which is $4.99, and then up here in our tax function, at the very end, it's going to return the taxes, and then it'll be able to print out that number, whatever that number is. So let's keep stepping through it and watch what happens. So now that I've called the function, it's going to go to the function, and it's going to start figuring things out. Remember that you have a variable in your function called price, which is the same value as item price, but you always want to have a different name for that value for your function. Okay? I know it stands for the same thing, and oftentimes people will call this variable price as well, but it just causes you to get mixed up between what's in your main program, what variables are available in your main program because they're global variables, and what variables are available or are accessible from your function. Remember that price only exists inside this function. GST, PST, both taxes, they only exist inside this function. I can't access them outside of the function. So that's why we name them differently, just to keep them separate. So we sent the item price up to the function, and then it becomes price. So the variable price is $4.99, the same as what we sent it, but price is only going to be available for the next, 4 lines. Okay, so now it just reads the next line and it says, well, there's a GST of 0.05%. So now you see it put a in our variables window, it's got GST as a float, 0.05, and then it's going to do PST, same thing, 0.06 this time. And now it's going to do a quick math calculation, both taxes, it's going to add the two, and it's going to say, okay, both taxes is a float, that's 0.11. Now it's going to do the calculation and the work. So it says return, so it needs to send something back to the calling function. Okay, that was the original function down here. We called it and we said, here's our price. This last line in the function is the reply from the person on the other end of the line. I'm going to reply to you with your total amount of tax. So all it's going to do is going to take the price, $4.99. It's going to multiply it by both taxes, which is 0.11, and then it's going to just send us back the answer, and it's going to print the answer. Okay? So it sent us back the answer, and then it printed down here at the bottom. I'm not sure if you can see that. You see that now there? Where it says the total amount of tax for this item is 0.5489. So that's really, if I rounded it, it would be 55 cents. Okay? Now, maybe I should go in there and put proper currency formatting in. For now, I'm just going to leave it with 4 decimals. But we know if we're ever dealing with money, we should make a, you should use that currency formatting that I put in assignment 4.1 to 4.3, whatever that assignment was. There was a paycheck question where I said you have to use this little chunk of data here to format it properly. I didn't do that right now. I just manually put in a $sign. And yes, there's 4 decimals and there should only be 2. But for the purposes of what we're doing right now, that's probably okay. So we've created a little program. We've created a function that works properly. Okay? And all we asked it to do, was to accept a number. All we asked this function to do is accept a number, that was the price, do some quick math on it, and then send back the answer. So in this case, the answer was 0.5489, or if we rounded it, 55 cents. So that's kind of one part of our problem here. We took a dollar figure from the user, check. We made sure it was a float because we knew it had to have decimals. We computed the tax, check, and we returned the tax. So that's great. The second part of our program was it says compute the final bill. We haven't done that. Now we could do a very simple calculation where we take $4.99, add on the 55 cents, and then display it for the user. But we could also create a quick little function to do that as well. So let's just create a function just so we get practice with it. So what we're going to do here is we're going to create another function, and we're just going to call it final price. So final price is going to be the price of the object with the tax. So what we need to do here, is we need to take the original price, and we need to take the tax, and we need to add them together. Now we're going to run into a bit of a problem here, okay? And I'll explain it in a second, but some of you have probably already figured out what the problem is. If we need those two things to figure out the final price, then we have to set up our function so it takes 2 pieces of data, the item price and the tax, and then adds them together. Well, getting the item price is easy because we can just use price again, which is going to be item price. So it's easy to send it the item price, but how are we going to send it the tax? Okay, so I'll call this variable tax. This is the problem, and we're not quite set up for it properly. Okay, the problem is that we called this function down here, and it returned our tax, but we never saved that number. We never saved this 0.5489 number, which means if we didn't save it as a variable, we can't send it back up to get the final price. So what we're going to do is we're just going to change this program just a little bit. What we're going to do is we're going to say total tax, and I think I might have used that variable name up here. Both taxes, no, okay. So I'm going to call it total tax is equal to, and then I'm just going to take this function out of here, and I'm going to put it up here. So when I do that, what it means is I've created another variable called total tax, and instead of calling the function inside my print statement, I'm just going to do it ahead of time so that I can actually save the number instead of just displaying it. So now I've taken this function and what was returned by the function, I've saved it as total tax. So now that I've got it saved as a variable, now I can use it whenever I want. So all I need to do is I need to put in total tax instead of this function, and it'll still look exactly the same when I run it. It'll still give us this exact answer. The only difference being I actually saved it as a variable so I can use it as many times as I want. If I don't save it as a variable, it's kind of like a one-time thing. It'll compute it and it'll return it and it'll put it down here, but it won't save it. So if I need it again, I have to go back and run the whole function again. So I've just saved it as a variable. Now I'm set up in a better place in order to do the final bill with the tax included. So I'm going to print a new statement. So now I'm going to print the total bill, or the total price of the object, or the item with tax is, then I'll put the $sign. And what I need to do now, I don't think I need to save the final price. I just need to display it for the user. I needed to save the tax because I needed to use it again. I don't need to save the final item price. I could, but I don't really need to. So this time I will just write in the function, and our new function was called final price. And I need to send it 2 pieces of data, right? It's set up to accept 2 pieces of data. It needs a price and a tax. So that means I have to make sure I send it 2 pieces of data. Otherwise, it won't work. And remember, it goes in order, okay? So price up here is going to be whatever I put in first, and then tax up here is going to be whatever I put in second, separated by commas. So for the final price, it needs 2 things. It needs the original price, which is item price, right, which is what we get from the user. And it also needs the total tax, which we calculated before. So that was stored in this variable, total tax. Okay, so now I've sent it 2 pieces of data. I send it item price, which goes up and is just going to be, that's the argument I send up. So whatever the user types in as item price is going to be used for price up here. And then total tax, I already calculated it, so it's going to send that up, and that's going to become the tax up here. Now my program isn't finished because I haven't finished my function for final price. This could just be a 1-line function. That's all it needs to be, because we can return the price plus the tax. That's all we need to do. So we sent it the price, we sent it the total number of tax. So in this case, we sent it $4.99, and then we sent it whatever 55 cents or 0.5489 cents. And then all our function is going to do is going to return the price plus the tax. Now, I know you could do that inside your program down here. I mean, it's a very small function. It's, if you were just doing this once, you probably wouldn't bother making a function. But what if you needed to determine the price and the tax of a million different items? Well, you wouldn't want to have to copy and paste and figure all this stuff out a million times. You'd rather just make one function and then call that function whenever you need it. It's like the difference between, for Reborg, if we turning right, would you rather type out turn left 3 times every time you need to turn right? Or would you rather just put in the one little chunk of code that says turn right? Obviously, it makes more sense to make the function for turn right and then just call that function whenever you need it, as opposed to taking the 3 lines of code and copying and pasting, copying and pasting, copying and pasting. Your code just gets really long and unmanageable. So now we're set up for both of those calculations. The first calculation, we already know it works. We tested it. So the first thing it's going to do after it takes the price is it's going to go and find out what the tax is, and then it's going to print out, this is how much tax you're paying. Then the second thing, it's going to access the final price function, and it's going to say, this is how much the item costs with both the taxes. So it's doing all of the things we asked it to do. It takes the dollar figure, it finds out what the tax is, it returns the tax, and in this case also prints how much the tax is, and then it computes the final bill and prints the sentence that says your final bill is this. So when I run this, I'll run it again in step-by-step mode here. So it says, first step, it says, hey, there's a function called tax. Great. So it doesn't do anything with it, but it just identifies there is a function that exists called tax. It'll do the same thing with this one. There is a function here called final price. We haven't used it, but we know it exists. Okay. We also created an item price variable. Sorry, I've got a little window in my way here. Created an item price variable, set it to 0 for now, and then right away it's going to replace it because we're going to get some input from the user. So F7, show them the right thing. F7. How much does the item cost? Okay, we'll put in $4.99, $4.99. Right, so now it's got item price is now afloat, $4.99. Now it's going to compute the total tax and save it in a variable called total tax. So it's going to run the tax function, sending it the item price. So it did that, and up here it's figuring out what the tax is, running the function, and now it's going to return the price times both taxes. And look what happened here. Our total tax variable now says afloat 0.5489. So we stored 0.5489 in a variable called total tax. Now we can use total tax. So the next line is print out the total amount of tax is total tax. So it's just going to print out whatever that variable is. So if we look at, I feel like my window got smaller for some reason. Okay, so now this is almost, this is kind of like 3/4 of the way through our program. How much does the item cost? I typed in $4.99. It ran the tax function. It says the total tax for this item is 0.5489. And then we're not quite done. Okay, now it's going to print the total price of the item with tax is, and it's going to run the final price function by sending it the item price and sending it the total tax, both of which I have saved in variables. So now it's going to go up to the total price or final price function. The price is the same as it's always been. That was just the original item price, $4.99. The tax, we calculated and sent it up, and you see it's 0.5489. And then all it does is just one simple math calculation. It's going to return. So it's going to send back whatever the price is plus whatever the tax is, and then we're going to get a final dollar figure. So when I run this, last line, you'll notice that we have one more line to our program here. The total price for the item with tax is $5.53. We got 4 decimals, but really, if we'd have rounded it properly, it would say the total price for the item with tax is $5.54, which makes sense. I mean, that passes the mental check, right? Our tax is about 10% of our price. So if our price is $5, the tax is going to be about 50 cents, which means $5 plus 50 cents should be about $5.50. So just a quick little mental check using 10% instead of 11% and using 5 instead of $4.99 tells us it should be about $5.50. Our final answer is $5.54. Passes the mental check. Everything looks like it's good. Step-by-step debugging said that everything was working properly. I was getting the right input from the user. I was sending the right input to the functions. I was getting back the proper result with the return statement, and everything worked fine. So once you've got your program set up properly and working properly, you can go back and you can make changes based on what you think needs to happen or how you can make it more efficient. And making it more efficient isn't necessarily always better. For instance, I've got some extraneous or extra data up here that I don't really need. I put it in here just to demonstrate how we're using each of these taxes. Like for instance, instead of putting GST equals 0.05 and PST equals 0.06, I could have just put in both taxes equals 0.11. Okay, it would work the exact same. Nothing would change in our program. In fact, I'll do it and I'll show you. So if I get rid of this right here and I change this to 0.11 and run the program, it's going to work exactly the same way. So how much? $4.99. And our output at the end says, okay, the exact same as it did above. So that was an example of something that I could get rid of if I wanted to. But this way is also more flexible. Let's say the government comes out tomorrow and says we have to raise the PST. So now it's going to be 7% instead of 6%. Instead of rewriting the program, if I've got it set up this way, I can just go to the PST, change that to 7. And let's say that the GST changed from 5 to 7 as well. It's before your time, but the GST used to be 7%. So let's say they go back to that. They say we got to raise the GST to 7%. So I can just change those 2 lines, and now my program will still work, and it'll work with the updated numbers. So if I run the program again and put in the same $4.99, now it gives us different numbers because we changed the tax rate. And you can see, get to my output line here, how much does the item cost? It's still $4.99. How much is the tax? Well, this time it's about 70 cents, right? And so because the tax is about 70 cents, now the total price is about $5.70 instead of $5.54. So that's one thing that you could have done to make this particular problem or this particular program a few lines shorter, is to get rid of the GST PST lines and just hard code the tax into the both taxes box. But it takes away the flexibility for you to change these ones independently. Okay? So, if they change the tax, the PST to 10%, I just got to change that one number there and run it again, and now it'll give me updated numbers based on a 10% PST. You notice that the final bill and the tax are both different now. So there's always a balance there that you got to walk between, or a line you got to walk between, making your program efficient as far as how many lines and how many things it has to do, and also making it flexible so that if things change, it's easy to update your program without having to completely retype it or fill in a whole bunch of different lines with new data. For instance, if I didn't have a function for tax, if I just kind of did it manually down in my main program every time, if I didn't call a function, let's say I had to compute the tax 100 times. Well, if I hard coded my tax down here, where I took the price and I multiplied it by the tax, and the tax was 7%, and I had that in my program 100 times, well, what happens if they change the tax to 8%? Well, then I got to go to each one of those 100 lines and change 0.07 to 0.08. Whereas because I have a function up here, I only need to change it in one place. I just change it in the function, and the rest of my program still works perfectly. So it's really important that you use variables effectively, that you know what data types you're going to need, and that you are able to build your program with enough flexibility that things can change and your program will still work, and keeping in mind that you also want it to be as efficient as possible. So it's a balancing act that you've got to work with in order to make sure that kind of all of those things are covered. For the programs in this course, I'm sure you've noticed, I'm quite specific about what your input needs to be and what your output needs to be. I give you examples. So you don't have to worry so much about that flexibility when you're doing the assignments, because I kind of tell you what I need. And it's not going to change, right? You're going to create this program once, you're going to hand it in, I'm going to mark it, and then we're done with that program and we move on to the next one. But if you're working in the industry, you're not going to be working with a lot of what we would call one-off programs. You're going to be building programs for companies or institutions or whatever that are going to change over time, because taxes change, and the data that you might need changes, and people change, so you've got to build things that are flexible and set up to be able to change with the times. So that is a very important concept in computer science and in programming. But it's one of those things that you kind of grow into. You don't necessarily, it's more important right now that you understand the foundations, which means you understand what a function is and how to call a function and how to send a function data, whether it's a price or a name or whatever it may be, and how to return data from a function. Those are the really important things in Computer Science 20, and the how to structure your code most efficiently, and the how it relates to what you'll likely be doing in if you choose to pursue computer science programming in university or college, or if you get a job or start your own company. the more education and the more you do in the business world or in the IT world, the more important it becomes to build those problem-solving skills in with regard to flexibility and efficiency. And also, we don't really need to worry about data efficiency all that much with our programs, because computers are really good at storing and working with numbers. That's what they're made for. And we're not sending it a billion lines of code. We're sending it, maybe 40 or 50 lines of code at the most, which means any computer, any computer can handle it, no problem. But when you get on a bigger scale, like all of a sudden you're at Google and you're sending trillions of pieces of data every second, that takes electricity, and that takes storage space, and storage space requires computers, and electricity, requires an electric grid, and storage space and internet bandwidth and things like that. So when you're dealing with large companies and large requirements for data, those tiny little efficiencies, they all add up to millions and billions of dollars each year. So again, we're dealing with small data sets, so it's not going to slow down our computers if our programs aren't perfectly efficient. But when you scale that up to a huge multinational corporation that requires huge amounts of data, those little amounts of efficiency add up pretty quickly, and they add up to people time, and they add up to dollars. So it is important to understand how these things kind of scale up to larger sizes. Okay, so that's an example of a useful fruitful function. Okay, we had a function, we gave it something, we did some math with the function, and it called it back. Now I want to use the same program I've got here just to demonstrate a couple things, particularly about local variables and global variables. I did go over this in the last session, but it's really important. So and it does cause some students some questions. So I want to identify right here the difference between local and global variables again. Okay, so price is local, and what local means, it's just like a neighborhood. Okay, let's say you've got your little neighborhood, your crescent, and your house is on your crescent, or departments in your crescent. Let's say you've got a skating rink in that area, and the skating rink is only available to people who live in your neighborhood, which means if you are in Meadow Green, only people from Meadow Green are supposed to use that skating rink. If somebody comes from the other side of the city, they're not supposed to be using your neighborhood skating rink. So that's an example of how a variable is local and can only be used by that neighborhood. In this case, let's just use this tax function. The neighborhood is tax. Okay? Anything underneath and indented is part of that neighborhood. Okay? So anybody underneath this and indented has access to price, and price would be the skating rink in this case, right? So you can access price in here because you're part of the neighborhood. As soon as you get outside of that neighborhood, as soon as you get outside of that tax function, price is no longer accessible. Okay? You are not in the neighborhood, you're not allowed to use price. And the same thing for here for final price. Final price would be the neighborhood, and then price and tax are only available inside that function. You can't access them outside. And I'll show you an example of what happens when I try to access it. So in this case, price and total tax, and tax are local. Okay? Item price, global variable, which means it can be used by anybody. So let's use item price. The example would be maybe it's like the Sasktel Soccer Center. It doesn't matter what neighborhood you come from in the city, you can all use the soccer center. You just need to go there, and they don't ask you, hey, where are you from? Because if you're not from the right place, you can't use this center. No, they just say, okay, you're in, you got a hockey, you got a soccer game here, go in, go do it. Doesn't matter where you're from. So item price is a global variable, and this is still item price. I just changed it from 0 to whatever the person put in. In fact, this line is not necessary. It doesn't matter, because right here I create item price, I say be a float, I give it some data, but it is a global variable. It means I can access it from anywhere in the program, including inside the functions. Okay? And total tax is also a global variable, and you can usually tell which ones are global just by looking at the code. If they are indented or not indented, if they're all the way on the left side, it means they can be accessed by anything. A lot of times you'll see that your global variables are at the very top of your program. So, good coding practice would probably be to put those variables at the very top. So usually it's your global variables at the very top, and then your functions right below it, and then your main code below your functions, right? You never want to have your functions at the end of your program. So if I had these things down here, that would be poorly constructed code. You always want to have your functions at the top, so people reading your code could say, okay, here's the main things that this program needs to do, and they're right at the top, easy to access. And any variable that's on the far left margin is likely a global variable, so it can be used anywhere. And any variable that is indented, like GST, PST. Did I freeze? Can you still hear me?
Yeah, I can.
No, we're good. Okay, so any variable that's indented and inside another structure is only available inside that structure, and it doesn't just mean for functions. It could mean for loops. It could mean for if statements. Anything that's indented is probably a local variable. Okay. Oh, and both taxes in this case, price is local, PST, GST, and both taxes. Those are all local. Okay, because they all only exist in that function, so they only exist in that one neighborhood. And here it's just price and tax are the local ones. Item price is global, total tax is global. Okay, now I'm going to show you the implications of this. Okay, let's just say I try to print out. Okay, let's just say I try to print out a variable. I'm going to take my input price, and I'm not going to make it an input statement anymore. I'm just going to put in the number 4.99. Okay, because I don't need it in order to demonstrate the next thing. And I'll take my total tax, and I'll just call it, whatever, 0.23. Okay? So don't think of this program the way we were thinking of it before. This is just to demonstrate local and global variables. Watch what happens if I try to print out item price, and then right behind it I'll print out total tax. Those are both global variables, which means it should have no trouble printing them. Okay, so when I run my program, you should be able to see that it just printed out the two numbers back to back, 4.99 and 0.23. It can access those because they're global variables. However, if I try to print out something that isn't in the neighborhood, so if I try to print out PST, it's going to give me an error because it's basically the computer saying you don't have access to PST. Oops. You don't have access to PST because you are outside of the neighborhood. You are outside of the tax neighborhood. That means you can't see what's going on in our skating rink. So when I run the program, you'll notice that it gets I get an error, and it'll tell me down here, okay, name PST is not defined. That's just the program's way of telling you we don't know what PST is because we're not allowed to see it. And it would be the exact same thing if I tried to access GST, or if I tried to access what else? Both taxes, or if I tried to access price, or if I tried to access tax. I should not be able to see any of those four things because those four things all exist in special neighborhoods. Okay, these three exist in the tax neighborhood, and these two exist in the final price neighborhood. Okay, but the idea is, I should probably put GST in here too, or PST, because that's another one that's hidden. These 5 pieces of data exist in my program. Clearly, they're in my program, but I can't access them because they're only local to those neighborhoods. So when I try to run it, just like before, I get the same error. It says GST is not defined, and it didn't even look at the rest. Okay, it just said it tried to find GST, couldn't find it, and then it has an error right away, and it says I'm not even looking any further because there's an error in this. I couldn't find GST, and it would be the same thing. If I got rid of GST and PST, now it's going to say name error. I don't know what both taxes is, right? So name error, both taxes is not defined. So that's a really important concept in computer science, is local versus global variables. Local variables can be accessed anywhere in your program by anything. Local variables can only be accessed inside that structure that they're in. And just to demonstrate that a little further, now some programs handle this a little differently, so I'm kind of actually just testing this right now. But let's say we had an if statement or something like that. So we've got these two global variables, and let's just have a little if statement here. So if, we'll just say if true, so we know it's going to run. Okay, if true, x equals 5, and then I'll just print x. Okay, and I don't need an else because I know it's going to run. So what happens down here if I try to access x individually? All right. So let's say I'm outside of my if statements. Now I'm outside of the neighborhood of my if statement. Now what happens if I try to print x? Okay, I want to walk through this step by step because the process is important on this one. So step by step. First line, it says, okay, there's item price, it's $4.99, that's great, I'll put it in there. There's total tax, 0.23, I'll put it in there. If true, well, it's going to run because it's true. I didn't have any logic in there, I just said if true, that means it's going to run regardless. So if true, x equals 5, it says, okay, great, there's a variable called x, it's an integer equals 5. Now it's going to print x, and so it's going to print 5, and it should do that successfully because the print statement is in the same neighborhood. It's indented, it's in the if statement, so it can access x equals 5. So it will print x equals 5. Just scroll down here so you can see it. So it printed 5. Now, what happens when it gets to this line where it says print x again? Okay. Oh, it did. It was able to access that. Okay, good. Actually, some programs handle that in different ways. So it looks like x is considered a local variable if it's inside an if statement, but it certainly isn't when it's inside a function. So that's actually kind of a important thing about Python. So each language is different, but in Python, and that's why I had to test it. In Python, it would appear that if you put variables, if you create variables inside if statements, they're created as local variables. And I'm actually a bit curious if it's the same thing within loops. So let's just try a quick loop here. And we haven't done looping yet officially in the Python unit, but we did do it in Reborg, so we do know that we can loop things. So let's just do a. You may not understand this yet because you're not quite there, but this is how you do a repeat using Python. You would do say for y equals for y in range 2, which means it's going to run 2 times. I'm going to create a variable, and I'm going to say x equals 5, and then I'm going to print x. Okay, so basically this is going to run 2 times. It's going to run once. It's going to say there's a variable that is equal to 5, and then I'm going to print 5. Then it's going to go back up. It's going to do the exact same thing. So it's just going to print 5 twice. And now, is it going to print y the third, or sorry, x? I meant x. It's going to print 5 because x equals 5 twice. Is it going to print x the third time? Because if it prints x the third time, it means that we could access this variable from outside of the loop. And if it did it for the if statement, I suspect that it will also do it for a loop. But let's try it. So I'll just step through it because I always think that's the best way to go through it. Again, creates item price. We're not using it this time. Creates total tax. That's fine. Now for y in range 2, so this is going to loop twice. So the first thing it does, it sets a variable x equals to 5. There it is. Then it's going to print 5. So there it did. Now it's going to do this again because I told it to repeat twice. So it says, okay, well, there is already an x, but I'm just going to overwrite that x equals 5 with another x equals 5. Then I'm going to print it again. And now I'm outside of the loop, so I'm going to go to the next thing outside of the loop, and I'm going to try to print what x is, and it says I can still see it. So I guess in Python, okay, if you're using an if statement or if you're using a loop, those are considered local variables. So you can create variables inside if statements and loops and access them from outside those loops. But you cannot with functions. Anything inside a function, I'll just call this test fun for test function. Okay, so anything that's created inside a function cannot be accessed outside. So I'm going to print. Okay, so I'm going to try to print x. I can see that x is a variable and that it is equal to 5. But that it is inside a function. So if I try to print it, it should give me an error because we don't have access to whatever's inside that function. So when I run it, now I get the error again, x is not defined. And that would be the same thing. That would be the same thing with any type of variable. So, you know, if I say hi equals hello, or if I say bool1 equals true, I won't be able to print any of those things. So if I try to print whatever is in the hi variable, it says I don't know what hi is. If I try to print what's in the bool1 variable, it'll say I don't know what bool1 is. Okay? So just be careful about that. If you're creating custom variables inside your functions, just know that you won't be able to access them outside the function. The only way I can access x, hi, and bool1 is if I return them. Okay, so if I return, let's say I return hi. Okay, so if I need to access hello, the word hello, okay, I need to have my function send it back to me. So that becomes a fruitful function. So instead of printing hi, I would need to print test fun, because it needs to run the function. And then when I run test fun, it's going to set these three variables, but I only tell it to return one. I'm only telling it to return hi. So it sets x equal 5 and it sets bool1 equals true. But the only thing I'm asking it to send back to me is the hi part. So when I run this now, it will work. Okay, see how it says hello now? Okay. Because I didn't try to print hi, I tried to print the result of running test fun. This is also an example of a fruitful function that didn't require any input from me. You'll notice up here for test fun, I'll get rid of these now because I'm not using them. Okay. Need this either. Okay. So you'll notice in my function test fun, the brackets are empty. I'm not sending it anything. I'm just saying, hey, whenever I run test fun, the only thing you need to do is create a variable called hi, a local variable that can only be accessed inside this function. And then I want you to send hi back. So when I run test function, I'm not sending it any data. It's not receiving any data, but it's still going to create the variable and it's going to return something. So as long as it returns something to the program, it becomes a fruitful function. And those are the vast majority of functions we're going to be using in this. Fruitful because it returns something to the calling function. This is the calling the function down here, right? Getting them up on the phone, saying, hey, test fund, do your thing and send me what the result is. And you know, up here, I could have returned anything, right? Well, what happens if I return 5? It'll still work. Except this time it's going to print 5, right? Because I didn't tell it to return hi, I told it to return 5. So now when I ran test function, I printed test function, and test function returned 5, so really it was just print 5. So that's an important concept, that this is a fruitful function even though it doesn't take anything. Now I'm going to demonstrate the difference between this and a void function. So here's a void function. Void function does something but doesn't return anything. So as soon as I get rid of this return statement, it is no longer a fruitful function. Now it's void. So I can have it do the same thing. If I print hi up inside my function, okay, if I print hi up inside my function, and then instead of printing the function, I just run it. So this time, you'll notice I don't have a print statement. I'm saying run test function. Okay. So when I run test function, it goes up and says hi equals hello, and now I need to print hi, and I can access hi because I'm in the same neighborhood. They're both indented, and I get the same result. I get hello down here. But the difference between this and the other one is this one's void because it didn't return anything. It did something. It printed hi up in the function, but it never returned anything back to the calling function. It never returned anything to test fun. All it did was take an instruction, said, hey, test fun, do your thing. And test fun picked up the phone and said, okay, I'm going to print hi. And then it's done. Phone call ends. It didn't send anything back to me. It printed it, but it didn't send anything. So it's very important to know the difference between void functions and fruitful functions. And the main difference is that a void function doesn't return anything. It takes things and it does things, but it never returns anything. It can take data. Okay, this is another thing that people sometimes get confused. I can send it data. Let's just say if I have, let's say I create my hi out here. Hi equals the word hello. And now I'm going to get rid of that in my function. My function, okay, is going to receive the variable, okay, and I'm just going to call it x up here. Well, okay, maybe I'll call it hi hello. I don't like to name them the same things. So here's what is happening, and I've got to change this one to hi hello. So this is still a void function. It doesn't return anything. It's the easiest way to tell if a function's a void or fruitful. If it has a return statement, it's fruitful. If it has no return statement, it's void. So it can still accept data. What's happening here is I'm creating a global variable called hi. You can tell it's global because it's outside of the, all the functions. It's lined up all the way to the left. So this is a global variable, which means it's accessible anywhere. But I'm going to send test fun was our function. I'm going to send it some data this time. I'm going to send it whatever is stored in hi, and the word hello is stored in hi. So when I run the test function, test fun, it sends up hello, the word, as an argument, and then hi hello up here receives it. So hi hello from this point down is the word hello, and then it prints hello, and then the program's over. It's still a void function. It didn't return anything to my main program. It did something, okay? And the things it did was take the data and print the data, but it never returned anything. So it does something, and it's taking data, but it's a void function because it doesn't return anything. So when I run this, it still works, and it prints hello, but because it didn't return anything back to the calling function, it's considered a void function. You will use void functions. I mean, they do have their uses, but most of the programs in this course are set up, and most of my assignments are set up to get you used to using fruitful functions. So usually with your functions, you're going to do something like that tax program. You're going to take some data from the user, or you're going to take some data from wherever. You're going to send it up to the function. The function's going to do something with it, and the function's going to return data. It's not just going to print something. It's going to return it down to the calling statement. So here's an area of confusion that hopefully I can help you with before it happens. Let's just say that we have a function that takes, I'll just call this data1. And all I want it to do, okay, is take data1. I'm going to return data1 plus 1. So really all this function up here does is it takes in a number, and then it'll add 1 to it, and it'll return it. Okay, now here is something that confuses some students, and everything's written properly, so it doesn't give you an error, but you don't get the result that you were expecting. So this would be an example of like a semantic error. So if I try to run test fun, and I send it the number 5, you would expect that the output would be 6, because test fun is just set up to take a number and call it data1 for now, and then print out whatever data1 plus 1 is. So if I send it 5, it should print out 5 plus 1 is 6. Okay, so this is the mistake that students make quite often, is they'll set everything up properly, and they'll run the program, and then nothing happens. You'll notice down here, nothing happened, but the program didn't give me an error. It didn't break because it's not broken. The reason it didn't do what you wanted it to do is because you just ran the function here. You didn't actually tell the computer to print anything. So a lot of times students will forget that if they are using a fruitful function and they're receiving something back, usually they have to store it as a variable or print it or both. So if I had changed this so that I have, let's just call this original data, and set that equal, I can't use space, original data. So I create a variable and I say I want original data to be equal to the result of running test function, sending it 5. Now I've actually stored the data. I can run my program again. I'm still not going to get it printed out though, right? It ran, it didn't give me an error, it didn't print anything out. I created a variable, a local variable, that will store the result, and you can see it over here, okay? Original data is now equal 6. So it did store it, but again, I didn't tell it to print it. So it didn't do anything other than store it as a piece of data. So, I can, if I want to keep the line above, I can just go print original data. I guess this wouldn't be original data, this would be new data. Because it's sending a 5 and getting something back. So original was not the right word to use there. So we'll call this new data. So now that I've stored 5 plus 1 into new data, now I can print it. And I'll get 6 down on my print line down below. So I print it. There's 6 right there. So now I actually did something with the data. I both stored it and I printed it. Or you can do that all in one line, right? If I don't want to store it as new data, I can just say print, okay, and then test fun, and then what did I send it? I sent it 5. You can send it whatever you want. I'll send it 10 this time. And now it should print 11. So it's a very minor error, but it's a semantic error. And it can be frustrating for students because they'll build their function properly. They will send it something. It will be working in the background, but it won't actually print what you want it to print because you didn't tell it to print it. You just told it to run the function. And that's a little bit different than reboard because when you tell it to move, you see it move. You don't have to like print move or anything, right? Where in this case is we're mostly dealing with data, numbers, words, Boolean. And if you want something to show up down here in the interpreter, you actually have to tell it print this. So hopefully I can kind of catch that error before it happens on any of your future programs because it can save you some frustration. I know I often get emails from students saying, I know this is programmed properly and it doesn't work, and I did a step-by-step and everything is working properly. I can't figure it out. And I'll say, you just forgot to print your thing. I mean, it's a really easy fix. You just go print whatever. But I don't want students getting caught up for hours because that was the mistake. And frankly, that's usually the case with errors in this class. They're usually really, really minor, like you forgot a semicolon or you forgot a bracket or you forgot to print something. Very rarely when students, do the learning and do the work properly, very rarely is there major stuff to change. It's usually just some minor little tweak, one minor little omission that causes it to not work properly. And frankly, that's programming. It's so syntax sensitive, right? It's like an English class where you can't spell anything wrong. Okay? You handed it an essay and you got 0% because you spelled one word wrong, right? That's how programming is. Not that I would give you 0%, but you get the idea. It stops, it breaks as soon as that first word is spelled incorrectly. And that can be frustrating for people who, sometimes move too quickly or, tend to make little mistakes and whatnot. And I'm one of those people for sure. It's usually those tiny little errors that can be frustrating to track down. If they're obvious errors, okay, like if I forget to send test fun data, it needs something in order to work because I said you should be receiving something that you can call data 1. If I don't send it anything, it breaks, but it tells me where it broke. It said, hey, test fun requires an argument for data 1. So I can look at that one line, even if my program was 100 lines long, I can look at this error and it'll tell me exactly where I went wrong and what's wrong. It'll say, oh, okay, it's, now it's obvious for me. I need to get something to put into data 1. I didn't send it anything. So now I can go back up and say, okay, now I'm sending it something. Now it's fixed. That's an easy error. That's an easy error to troubleshoot and fix because the program basically told you what the mistake was and where to find it. The tougher ones to fix are the ones like this, where everything's working and it's running. You can tell it's running, but it didn't print what I wanted it to print. This one's not bad because the program's all of 3 lines long, but you can imagine if you had an error like that in the middle of a 200-line program, it can be difficult to find out exactly where it is and to troubleshoot it and to understand where the error is and how to fix it, which is why step-by-step debugging is so important, and I've tried to focus on that so much, is if your program runs, but it's not giving you the proper output at the end, you can either look at 200 lines of code and try to pick it out by eye, or you can run it step-by-step, checking your variables, and sooner or later you get to the step where it says, okay, it's supposed to print 6 here, and you run that step and it doesn't print 6, well, now you know, in line 8 or line 5 in this case, I forgot a print statement, I fix it, I try it again, and it either works, or I go back to step-by-step and find the next mistake. So it's really important to understand step-by-step debugging. It's pretty easy to look at a 4-line program or even a 10 or 20-line program and find out where your error is. When you've got 200 lines of logic and a bunch of different functions, it is very, very difficult to just look at it and find out where the error is. You need to run it up until the point where the mistake is made and then identify what you need to fix, especially if the program runs, but it doesn't give you the right data. All right, that was a pretty good chunk of review there for functions, both void and fruitful. Are there any questions? I'd love to have them, answer them.
I saw there were 2 Python exams. What will the other one be about?
Oh, sorry. I had my volume down. Can you say that again, please?
I think I saw that there was gonna be another Python exam. What is that one gonna be about?
That one's going to cover everything from the beginning, so 4.1 all the way up to the end of 4.8.
Okay then, thank you.
It's going to focus more on the material from say 4.4 to 4.8, but you still need to know all the stuff from 4.1. In math, it's like it would be like the equivalent of trying to learn how to factor numbers without knowing how to add and multiply. So you need it in order to do the second exam.
Okay, thank you.
And that second exam starts when? Next week? Yeah, next week, Wednesday. And just like this one, I give you almost a full week to complete it. So that's all good. I haven't marked any of the exams yet. It's not due until Thursday, so I'm not even going to mark until then. I will say one thing, though. Because I haven't even looked at the practical portions, if you feel like you learned something today or revised something that you know you did wrong on the practical exam, and you want me to clear that out so that you can just rewrite it and submit a new one, that's fine. Just send me an email and say, I think I made a mistake on the practical portion. I'll clear it out, and you can fix and submit. I won't give you a grade. I won't tell you what's wrong, but I will nix it out so that you can submit a new one if you wish. But just make sure you send me an email if you want to do that. Practical portion, I can't do that. When you're done the practical and it's submitted, it's submitted. Does anyone else have any other questions? Anything they don't understand, or were there any of those concepts on the on that page I showed you that we didn't get to? I'm pretty sure we did all of these. Romilly, you were there for the last one. Did we do logical operators for comparison?
I don't remember actually. That was a while ago.
Yeah, it was a while ago. Should we just? We already been on for an hour and 10 minutes. I'm gonna do this very quickly. Again, this is all review. I mean, these are all things that there's video for. So, you know, the live sessions are meant for enhancing your learning, not necessarily the original. So if some of these don't make sense, make sure you go back and make sure you've done the reading and that you've watched the videos for each of the PowerPoints. And also, it's not a bad idea if a particular command or function or word or something you still don't understand it, it's perfectly okay to go Google it or just to look in that digital textbook that's at the top of 4. It might be explained in there in a slightly different way that helps you, or you could send me an email. But I do ask that before you send me emails about how to do things and assignments and stuff like that, you have to do your due diligence. You have to have gone through the videos. You have to have done a little looking around and practicing before I'm going to help you. Otherwise, I'll send you back there. That's kind of part of your job versus my job thing. Okay, so very quickly, these logic operators, they're logical, so hopefully you don't have too much trouble with them. Okay, so the main logical operators in Python are less than, which looks exactly like it does in math class, greater than, same thing. Equals is 2 equal signs, and I'll explain why in a second. Less than or equal to, greater than or equal to, less than or equal to, and not equal to. So those are the ones we use, okay? Now, what I'm going to do is put these inside logic statements very, very quickly just to demonstrate how they work. So I'm going to create a couple variables. I'll create a equals, zoom in a little bit here. A equals 5, that'll be an integer. B equals 3, that'll be an integer. I will create, what else? That's probably fine for now, actually. So inside a logical statement, you have to make comparisons, right? Because we know for our if statements, it has to be either true or false. Okay, if it's true, it's going to run what's under the if. If it's false, it's going to run what's under the else. And you can have elifs in there as well. But it has to have some sort of comparison. It has to do some sort of test to determine, am I going to do the if? Am I going to do the elif? Am I going to do the else? And that's where these logic comparisons come in. And you would have seen these in Scratch. If you've done all the Scratch assignments, you've definitely seen these before. I can't remember what color blocks they are, but I think they're all green. So you will have seen these before. It just looks a little bit different because it's in Python. And we didn't use these in Reborg, so you likely wouldn't have seen them in Reborg. All right, so let's just do a quick comparison. Let's look at A and B. So let's test if A is less than B. So if A, and that's the less than sign, B, I'm going to print out, okay, print first. I'm going to print out A is less than B. If that's false, else print A is not less than B. Okay, so that's a very, very simple if statement, okay, that requires a comparison. And the comparison is between whatever's in A and whatever's in B. Currently 5 is set for A and the variable B is set to 3. So it runs this first step and it's going to say, is this true or is this false? Only two options. So if A is less than B, and we could just look at that and eyeball it and say, is 5 less than 3? No. So because this little logic condition is false, it means it's not going to run the if, it is going to run the else, and logically it should print A is not less than B. So let's run it, and the result is A is not less than B, which is exactly what we would expect. Okay? So that is about as simple as it can be with regard to testing two operations or testing two variables and using an if statement. I can change this around very easily. What if I want to check if A is greater than B? I just need to change that from the less than sign to the greater than sign. So if A is greater than B, then we need to print A is greater than B. And then down here, if it's not true, we would say A is not greater than B. Now let's just eyeball it and see what's going on here. A is 5, B is 3. So is A greater than 3? Yes, it is. So this should result in true, which means it should do the if part, which means it should print A is greater than B. It will not run the else. It only runs one of the if, the elif, or the else. It'll never run more than one of those. We don't have an elif right now, but we will in a second. So when I run this program, it should say A is greater than B, and it does. If we do this step by step, okay, so quick step by step, it says A is equal to 5, B is equal to 3, there's our variables. Now it checks this part, if A is greater than B, okay? And what it did is it basically looked at these two and it said that is true. A is greater than B, which means I'm gonna run the if part, which is print A is greater than B, and then it's done because it doesn't run the else. So that's a quick how do you use less than and how do you use greater than. Well, let's just change these variables. Let's set these equal to each other. So now A is the same thing as B. They're both 5. If I run is A greater than B, that should be false because 5 is not greater than 5. So it should print out A is not greater than B. So it should do the else, and it does. A is not greater than B. Let's manipulate our logic a little bit to include the greater than or equal to. So now if we want to test more than if A is greater than B, okay, let's say we're testing is equal or greater than or equal to B. Now we're going to get a different result. Now we should probably change our output statement too. It says A is greater than B. We should say or equal to B. And then our second part, if that's not true, then we should say A is not greater than or equal to B. Okay, now just eyeballing our numbers, just looking at them. Is A greater than or equal to B? Yes, it is. It's equal to. So it should, this logic statement should evaluate true, which means it'll do the if part. So when I run it, it should give us the proper A is greater or equal to B, which is what we would expect. Okay? And if I flip this around and I said, is A less than or equal to B, I should also get true. Now, I'm not going to change the sentence, but it should print this. It'll print this first part because that's still true. Okay? No, A is not less than B, but it is equal to. So when I use less than equals together, it evaluates to true and it runs this part. So that's how you use the greater than, equal to, less than, equal to, greater than, and the equal sign. Because you use one equal sign to assign variable values. Okay, so A equals 5, B equals 3, hi equals hello. You have to have a different sign in order to compare if two values are equal. So that is why you have to use equals equals when you're comparing. So when you're setting variables, it's one equal sign. When you're comparing two values, it's two equal sign. So in this case, what we're checking is A equal to B? So is A the same as B? And if it is, then we would say A is equal to B. Or we would say, if it's false, we would say A is not equal to B. Now, if we run this logically, just eyeballing it, A is 5, B is 5. So is A equal to B? Yes, it is. So it should print A is equal to B. And when we run it, it does. Okay. What happens if we change B to 6? Okay, once again, quickly, logically, we know that 5 is not equal to 6, which means A equals B is going to be false. Okay. This is always your question here. When it says if A equals B, what you're really asking is A equal to B? Okay. And if it is, you run the first part, and if it isn't, you run the second part. So now we can see that A is not equal to B, so it's not going to run the if statement, it's going to run the else. It's going to say print, it's going to print A is not equal to B. Okay. So there we go. A is not equal to B, which makes sense, right? If I change A back to 6, now it's going to run the first part again because they are equal. Okay. So that's how you check if two things are the same. And you can also do that with words. Let's just say I've got X equals hi, and then I've got Y equals hi. If X is equal to Y, and X is equal to Y, or X is not equal to Y. So it can compare strings just as easily as it can compare numbers. So now we're not using the AB, we're using the XY. Is lowercase hi the same thing as lowercase hi? Yes, it is. So we would think just by looking at it that it'll print out X is equal to Y. It is. They're both hi. But they have to be exactly the same. If I change this to the word hi, which sounds the same but is not the same, now it says X is not equal to Y. And it's case sensitive. So if I ask, is lowercase hi the same thing as uppercase H, lowercase I, it'll tell me, no, those are not the same. It might be the same word, but it's not the same, case. So I change them both to uppercase H, lowercase I, now they're equal again. So you can compare numbers, you can compare strings, you can compare floats, you can compare all sorts of things using those. This is not equals. Okay, again, this is all in the videos, but this is not equal. So if I want to compare and I'm looking for something that's not equal, I can put exclamation point equals. So this is checking, are they different? Okay, so I need to swap these two around. Now I'm not checking to see if they're the same. Now I'm checking to see if they're different. Okay, so in this case, X is equal to. So it's going to check, and it's looking for, are they not equal? And if they're not equal, this whole thing evaluates to true. So let's look at it. Is X the same thing as Y? Yes, it is. But that's not what we're checking. We're checking, is X not equal to Y? And that is true. X is not equal to Y. So that's false, because X is not equal to Y. Oh my God, I got that backwards. Ooh, too much logic. X and Y are equal. So when I'm asking, is X not equal to Y? That's false, because they actually are equal in this case. There, I got it on the third try. Which means it's not going to run this first part. It's going to run the second part, because they are indeed equal. So when I run it, it's going to hit the if statement. It's going to check. It's going to say, no, that's false. So I'm going to skip over and run the else, which is going to say X is equal to Y. Now, if I change Y so that it's the lowercase hi, now these are no longer the same. So now when I'm checking, is it true that X is not equal to Y? I can look at them and say, yes, that's true. X is not equal to Y. So now this case, it should print the X is not equal to Y because it passes the test. X is not equal to Y. And the same thing with numbers, right? If I change this to A and B again, okay, so A and B, A, B, A, B. Okay, so now I'm just checking but with numbers instead of strings, right? Is A not equal to B? Is it true that A is not equal to B? That's actually false because they are equal. So this should print A is equal to B. So it should print the else here. Okay. A is equal to B, which is true. But if I change B to B7, now I'm asking, is it true that A is not equal to B? And you look up here and you say, yeah, that's true. A is not equal to B, 1617, which means that this whole thing evaluates to true because this statement is true, which means it's only going to run the if part, which is going to say A is not equal to B, which we know just by looking at it that those two aren't equal. Now, I didn't include an elif in here, so I'm going to include an elif in here and hopefully simplify it just a little bit. Okay, let's put in that. And let's create a new statement that does an elif. So I'm going to have an if, I'm going to have an elif, and I'm going to have an else. Remember, you can have as many elifs as you want. Okay. In fact, I'll put 2 in just for giggles. Okay. So the condition. Here's the condition. The first condition, if A is equal to B, then I want it to print A is equal. And now let's say I want to check something else. What if I want to check elif? Let's check is A equal to 3. And I just hard coded in 3 there. You don't have to. Not everything needs to be in a variable. I can check if the variable A is equal to any number, any string, anything I want. Okay, is A equal to 3? Well, we can see up there it's not, so it wouldn't run this anyway. So let's print A is equal to 3, but we know that's not going to happen because it's not. And then for our next elif, let's check if A is less than B. Okay. So let's check that, and if it is, we're going to print A is less than B. And then our else could just be if it's not equal to and it's not less than, okay, then it has to be greater than. So our else statement would be A is greater than B. And now let's just look at our numbers and see if that makes sense. So A is greater than B. All right, so let's look at our numbers. I only used A right now, I think A and B. So A is 6 and B is 7. Okay, is 6 equal to 7? No, so it's not going to run that one. Is A equal to 3? Is 6 equal to 3? No, so it's not going to run that one. And remember, it goes top to bottom, right? Is A less than B? Yes, it is. 6 is less than 7. So it should print A is less than B. And remember, it only does one of these. It'll only do one if, one elif, or one else. It'll never do more than one. So as soon as it says, hey, this one right here is true, it's going to print A is less than B, and it's not even going to bother looking at the else statement. So when I run it, we get A is less than B. And we look up at our numbers and we say to ourselves, well, that makes sense because A is less than B. All right, now what happens if I make A greater than B? Let's say I make A 9 and run this again. Okay, so let's run this again with A equals 9. Okay, and just logically, okay, is A equal to B? No, it's not. So it's going to skip over that one. Is A equal to 3? Nope, it's still 6. So that one's not going to. So that one's not going to run. Is A less than B? A, B. It is less than B, so it's going to print A is less than B. I actually wanted it the other way around, didn't I? I wanted it to be A equals 9 and B equals 6. Okay. Sorry, let's just check that again with the new numbers. Is A equal to B? No, it's not. Is A equal to 3? No, it's not. Is A less than B? No, it's not. Therefore, it didn't run the if, it didn't run this elif, it didn't run this elif. Therefore, it must run the else. It's the only thing left. So when we run it, it should say A is greater than B, and it does that because A is indeed greater than B. Okay, now let's run it with A equals 3. Okay, logically speaking, is A equal B? No, 3 is not equal to 6. Is A less than B? Yes, it is. A is, or sorry, the next one is A equal to 3? Well, this time A is equal to 3. So it should print A is equal to 3, and then it doesn't bother running anything after it. As soon as it hits a true condition, it's done. So it checked, is A equal to B? No. So it went to the next one, and it says, is A equal to 3? Yes, it is. So that's the one that runs, and nothing else runs. So it's important to understand in your logic statements both how to compare things and also the concept that it can only run one of these. It'll go until it finds something that's true. Okay, and if it finds something that's true, whether it's the if or any of your elifs, it'll run that statement. If all of those are false, then it does whatever's in the else. The else is kind of the catch-all at the bottom. Think of a big filter. You know, you put let's say you're ever seen Panning for Gold on TV, where they have a water pan and then they shake it around, and ideally all the water drains out the bottom and all the little stuff drains out the bottom, and you're left with just the gold, right? You're trying to filter things out using the if and all of your elifs, and then whatever's left over at the very end is the else. It's kind of the thing that catches whatever's left over. So that's how you can use logic, and that's how you can do comparisons. Now, one thing, you can compare more than one thing at once, and you can also use nots and or and in your statements, but you have to do it properly. I've already seen some errors about this, and I've already corrected some people on it. I actually didn't need to see here. No, maybe I will. So let's check now. Okay, I'm gonna take out the elifs just to simplify this a little bit. Okay, so now I'm going to use compound logic. I'm going to check for more than one thing. Okay, so if A is equal to B, or A is equal to 3, for this. So it's going to check two things. It's going to check, is A equal to B, okay, or A equal to 3. And we know that an or statement means it's just one or the other. Okay? If I put and, then it would have to be both, but an or means one or the other. So is one of those two true? If it is, it's going to run this step right here. So logically, we would say it does the first step, and it says, is A equal to B? 3 is not equal to 6, so no. Or is A equal to 3? Oh, yes, it is. So this whole thing becomes true because it fit the or part. So now it will print A is equal to B or A equal to 3. We don't really know. I mean, we know because we can see it, but it doesn't need to know. All it needs to know is that we passed one of these tests, which means it's going to run that. Now, if I say instead of A equals 3, I'll check if A is equal to 4. Now this isn't going to run, right? Because it's going to check the first thing, and it's going to say, is A equal to B? No. Is A equal to 4? No. So this is false, which means it's going to run the else, which in this case means A is not equal or to B or 4. Okay, that's all we know about it. Okay, so when I run this, it checks and it says A is not the same as B, A is not the same as 4, so neither of those are true, which means I'm going down to the else, I'm going down to the catch-all, and what we can say for sure is that A is not equal to B and A is not equal to 4. Okay. Now, a mistake that students sometimes make in this is something like this, okay? You have to include the entire set of logic. So this kind of makes sense when you're reading it. If A is equal to B or equal to 4, because you know that in your mind, you're still remembering that it's A that we're comparing. So you say, is A equal to B or equal to 4? You kind of can do that in your head, and it makes even a bit more sense if you do something like this. Is A equal to B or greater than 4? That makes sense in your head, but the computer is missing a piece of information. It knows what to do for the first check, but it doesn't know what to compare for the second one. It doesn't remember that A was being used in the first one. So you have to always put the entire, comparison in there. And that's a mistake that happens quite often. I mean, students will do something like this. If A, let's just say if A is greater than 6 or equal to 5. That's something you might say in a math class. Is A greater than 6 or equal to 5? And that works and makes sense in your head, but the computer doesn't know that you're still using A here. So if you say A is greater than 6, or then you have to also say A equal 5. We know we need 2 equals when we're comparing. So that's a mistake that happens. And another mistake that happens is using this. Sometimes you'll see this in math class, Or you've got a compound logic where it's like 6 is less than A is greater than 6. You've probably, not greater than 6. I'll use a different number because you shouldn't use the same number. But 6 is less than A is greater than 8. Or 6 is less than A is less than 10 or something like that. It doesn't know what to do with those compound logics. So you'd have to do it separately. If A is less than, or 6 is less than A, or A is less than 10, you're comparing two things, so you need to have two full statements. Okay, so that's important that you know that. And don't forget that you can use or, and not. Okay, so you can also use those. So we used an or, let's use an and. Okay, so let's say if A is equal to 3 and A is less than B. Okay, run A is equal to 3, or A is, what did I say? Less than B. So we just look at the numbers and we can see this is true. But the difference between or and is both of these have to be correct. If A is equal to 3, that is true. And A is less than B, that is also true. So this whole thing is true, and it will say A is equal to 3 or, and A is less than B, because that's a true statement. Because they were both true. However, if one of these is false, then it doesn't work. So let's say if A is equal to 3 and A is equal to B, okay, then print this line. We can look at this and logically say A is equal to 3, passes the first check. Is A also equal to B? Nope, fails the second check. So when you have an and statement, they both have to be true. In this case, only one is true, which means it's going to run the second part, which I haven't changed, but you notice that it ran this part here instead of this part here. So when you're using and or, make sure you understand that with an or, only one of the two has to be correct. With an and, they both have to be correct. And if you were to put another and in here, so let's say if A equals 3 and A equals B and C equals A, then we'll print A is equal to 3 and A equals to B and A is equal to C. Okay, so now it's got to have all three being true in order for it to work. Okay, so what have I got here? Oh, because C, right? So A equals 3 passed. Let's change B to 3 and run it again. So A equals 3, that's true. A equals B, that's true. Does C equal A? That's false. So it had 2 of the 3 correct that time, but not the third one. So this is false, which means it's going to print the else statement. If I change C to 3, now all 3 of those are true, right? A equals 3, true. B equals A, true. C equals A, true. Now it'll run the top part. And then it can get, your logic can be as complicated as you want. You can have ors and ands and nots, and you can have all sorts of things in here, and it'll operate differently depending on what words you put together and how you compare things. That's probably a bit more complicated than we need to do, but it's important that you understand that this is less than, this is greater than, that you need 2 equal signs when you're comparing in your if statements. That's greater than equals to, that's less than equal to, and that is not equal to. Okay, so you definitely need to understand these signs and how to use them in if, elif, else statements, and also while statements, right? Because you could very easily have something like while A equals 3, okay, print A. Okay? So that's logic. So, we did lots of this in Readborg, while not at the flag, or while, while in front, or something like that. That's a comparison, right? In this case, we're just using numbers. So while A equals 3, let's print A. And then if I put another line right underneath this that says A equals, or A plus equals 1, remember that's the short way of saying A is equal to A plus 1. So just add 1 to A is what that is. Okay, this will work because while A equals 3, the first time it runs, A is equal to 3, so it's going to run. So it goes inside and it prints A, which is 3. And then it adds 1 to A, making it 4, which means when it goes back up and checks this test again, A is not going to equal 3 now because we added 1 to it. Now, it's probably easier to demonstrate that if I step through it. So using F7, it just checks my variables, sets my variables. Okay, now look, A equals 3. So when it checks, while A equals 3. That's true. Okay, so it's going to run the while statement. Print A. Well, A is currently 3, so I'm going to print A. So it does 3. Now it says take A and add 1 to it. Okay, it does. So now you notice A is 4. So now next time it goes up to see if it should run the loop again, okay, it's going to say is A equal to 3. And now that's false because I changed it from 3 to 4. As soon as I added 1 to it, I changed A to 4. Now it's not going to run this loop because this is now false because 4 does not equal 3, which means it's done and your program's over. So you're going to use logic statements like that inside of your if statements. You're going to use them in your whiles, and it doesn't always have to be numbers, right? It can be words. Let's say A is equal to the word hi. So while A equals the word hi, I want you to print A, and then right after that statement, I'll say A plus equal hello. So after it runs the first time it prints, it's going to print hi. Then instantly it's going to change A to be hi, hello, and then it's not going to run again because this will no longer be true. So the first time it runs, stepping through it, okay, A equals the string hi. So there's A, it's a string, hi, B equals 3, C equals 3. We're not using those. While A equals the word hi, lowercase. Is that true? Yes, clearly the word A is hi, lowercase, so it should run in the loop, print A. Well, A is currently hi, so it does. Now it's saying take your A and add hello to the end of it. So now, if you look at A, it's now equal to hi, hello. Because when you use the plus sign with strings, right, it just puts them back to back. So now it's checking again. Does A equal lowercase hi? And this time it's false because we changed it to be hi, hello. So because it's false now, it's not going to run the loop anymore, and it's done. So that's a pretty detailed little look at logic and comparison and how you can use those symbols to compare numbers. And you can also use them to compare letters. And I use the equals here, but you can also use less than, greater than, anything. When you're comparing strings using less than or equal to, what it does is it takes the letter and the place in the dictionaries, right? So A is before B, B is before C, etc. So if I check if the variable A, let's do the letter N, okay? If I check if the variable A is greater than N, what it's basically looking at is it's saying is the first letter H. So we've got A is equal to HI. Is H greater than N? Okay, so H in the alphabet is going to be before N, right? H-I-J-K-N, or H-I-J-K-L-M-N. But in any case, H is before N, which means it's going to be a lower number. Okay? So think of A as 1, and B as 2, and C as 3, and D as 4, etc. So in fact, I'll just do it that way. So the letter A, let's just think of it as the number 1. Is the number 1 greater than the number 2? Because B would be 2. So we can actually compare that the same way. Okay, so I'll just, instead of that, I'll print alphabetically A is before B. So if A is greater than B, it would mean that B is before. If A is greater than B, it would mean B is before A. That in a bit of a backwards logic way, but the else on this, it's not an if statement, that's a while. Make this an if statement. So if A is greater than B, print B is before A, else print A is before. All right, so let's run this in logic, make sure it works. Okay, so it says A is before B, which means it did the else. So what was the check? The check is 1 greater than 2? And it said no. So it said this is false. A is 1, B is 2, therefore A is not greater than B. So I didn't run the if, I ran the else. Okay, now if I change the signs around, okay, or if I say is H greater than B, or let's just do C so I can keep my D, we'll do D. So the letter D, so A is 1, B is 2, C is 3, D is 4. So let's say D is 4 and B is 2. Now we're checking, is 4 greater than 2? And that is true. So then what this would say is B is before H. And if it's false, we would say H is before B. Well, we know that B is before H, so it should print B is before H because the letter or the value for D is higher than the value for B. And if you're really curious, I use the numbers 1 for A, 2 for B, 3 for C. It's not comparing those numbers. There's actual numbers associated with each letter. Lowercase a is 65, lowercase b is 66, lowercase c is 67. And the capital letters are even greater. So once you get down to the end of Z, then it would be capital A equals 100 and, whatever it is, 100 or 98 or whatever it is. Capital B would be 99, capital C. So uppercase is treated differently than lowercase. So if I check if I actually kind of did this. If I check if lowercase a, let's just check if lowercase a is greater than uppercase A, then we'll say A is before A, or we'll say A is before A. Okay, so let's just check. Is a lowercase a greater than an uppercase A? Okay, it is. So a lowercase a is greater than an uppercase A. I think I had those backwards then. So this is 65. So capital A must be more than that. I wonder if it'll print the, probably going a bit too far here, but ASCII values. Oh, sorry, it's the uppercase A that's 65. The lowercase a is 97. Okay, so I don't know if you can see that there. And we look at the letters over here. I don't know if you can see that. Okay, so all of these, basically everything on your keyboard has a number assigned to it. And if you can see over here, so basically everything on your keyboard has a number assigned to it. And I had it backwards. It's the uppercase A that's 65 and not the lowercase a. So uppercase A is 65, and then B is worth 66, C is worth 67, and so on. Then after you get past Z, it does a couple other symbols, this little quote symbol, and then it goes to lowercase a is 97, lowercase b is 98, lowercase c is 99. So what we were really comparing there was 97 greater than 65? And we know that's true, just logically speaking, that's true. And that's why, okay, when we were saying is A greater than A, what we were really asking was is 90, what did I say, 97? Is 97 greater than 65? Set the numbers. So just know that when you're comparing strings, it's actually assigning ASCII numbers. You don't need to know what that means. It's actually assigning a number to each character on your keyboard. So you could even ask something like this: is the equal sign greater than the plus sign? And it'll give you an answer because they're all worth something. I mean, this said A is equal before A. That's just I told it to print that. So really, what it's saying is plus before equals on the keyboard as far as what values are. So if we look at plus, equals sign is 61 and the plus sign is 43. So we said is the equal sign greater than the plus sign? Is that what we checked? Is the equal sign greater than the plus sign? And we looked at the chart and we saw, yeah, the numbers that are actually assigned to those keyboard values, that is true. So it printed this thing. That might be a little deeper than we need to go. All right, I've already kept you for far too long. But hopefully that gives you a little bit more information on some of these logic comparisons, as well as the very, very important concepts of fruitful functions, void functions, sending data to functions, returning data from functions, and logical operators. Because if you don't know how to use these logical operators, you're really, really, really hampered in what your program can do, because these are how it decides whether to do the if, the elif, or the else. This is how it decides, am I going to keep looping using a while, or am I going to stop? if you don't know how to do those, you're kind of stuck after 4.3. Okay, again, I took far too much of your time. Apologize for that. Are there any other questions? If not, I'll send you on your way, and we'll meet up again on Wednesday for some more review and Q&A.
See you on Wednesday.